Friends, so today we will study MScIT Part 1 Semester 1 Data Science subject, Unit number 4, Chapter number 10, Transform Superstep, Part 1. So in this chapter, Transform Superstep, that is chapter number 10, the first part is considered in Unit number 4 and the second part is considered in Unit number 5. So let's start. Transform Superstep. The Transform Supersteps allows a data scientist to take data from the data vault and formulate answers to questions raised by the investigation. Like if suppose we have a query like which type of students are ready to study data science or they are interested in graduating from data science. So such questions can be answered using the Transform Superstep. The Transform Superstep is the data science process that converts results into insights. The Transform Superstep uses data vault from the process step as its source data. It is tuned to work with 5 dimensions of the data vault. The 5 dimensions of the data vault are time, person, object, location, and event. So these 5 persons are considered as the 5 dimensions of the data and they all are connected. So you can see in this diagram, person is connected to object, location, time and event. So every entity is connected to every other entity in the TPOLE high level design. Now, Sun model, the use of Sun model technique enables the data scientist to perform consistent dimension consolidation by explaining the intended data relationship with the business without exposing it to the technical details required to complete the transformation process. So here the technical details are hidden from the user and only the how the entities are connected are considered here. So let's go to the person to time Sun model. Here we have the person entity and the time entity. Now person will have the person ID, then the first name, last name and the birth date. The time will have the time ID, the UTC, time, local time and time zone. So these two are connected by some relationship or you can say by some fact. Now, the Sun model is constructed to show all the characteristics from the data vault hub categories you are planning to extract. It explains how you will create 2 dimensions and a fact via the transform superstep. So, we have the person dimension and we have the time dimension. What we have to do? We have to find out the fact with which they are connected. So, the fact here is the person born at time. So, this fact is connecting the person dimension with the time dimension. Now, the template for the model. For any dimension, we should first have the key. So, key is important in both the dimensions and a unique key will be able to identify the record. That is why the key has to be auto-generated. At the bottom, we have the fact. That is, in the previous example, the fact was the person born at. And then we can add other fields like any number of fields that we want, like we can identify the first name, last name and other characteristics. Same way for the time dimensions, we can have the local time, UTC time and the time zone. So person to object Sun model. Now a person is connected to a particular object. So the person will have the person ID, person will have the first name, last name and the birth date. The object will have the object ID, then the species and the common name. So common name for this is human. Now person to location sun model. So person to location sun model, here we take all the details of the person like the ID, first name, last name and birth date, and in the location we take the location ID, latitude, longitude and time zone. Now person to event sun model. So here we take the person ID, first name, last name, birth date and the event that has occurred. So the person event ID is 0 and the event is born. So the person was born. This is an event. Now sun model to transform step. Here we take the person ID and the time dimension and we try to connect the person dimension with the time dimension, so we can apply any fact over here for making the connection. Transform from data vault to data warehouse. We have to build a data warehouse. So how to build a data warehouse? We have to take the information and we have to build. That means transforming with data science, we have to have good basics for data exploration and preparation from data lake into data vault and from data vault into the data warehouse. So first the data will be collected in the data lake, then it will be transformed into the data vault and from data vault it will be transformed into the data warehouse. Now, what are the steps of exploration and preparation? We have to make a treatment for missing values. If there are some values which are missing, then these values needs to be treated properly. Otherwise, these missing values will create a problem later. Now, why the missing value treatment is required? Because if the missing value treatment is not done, then the data may go wrong. Like suppose most of the students are in the age group of 18 to 20. Now, if a student's age is missing, so the average may get reduced, but as we know that the average age of every person is 19, so we can put a value 19 and the missing value can be completed. Why the data has missing value? Yes, this question is very important. Data fields. So the question may be asked in exam, data fields renamed during upgrades. When we are renaming the data fields, then the column may not be identified and because of which the values are missing. Second is migration. Migration process from old system to new system where mapping is incomplete. Incomplete tables supplied in loading specification by subject matter expert. Data simply not recorded. Data was not available at the time of recording. Like if a person has not specified the age, so the person's age may go blank. Legal reasons owing to data protection legislation such as the General Data Protection Regulation resulting in a not to process tag to the data entry. So if a data has a tag that the data cannot be processed as per the GDPR, so we have to keep it blank. Someone else, bad data science people are making the project, but if they are not collecting the data or if they have made the mistakes and they are not fixing these problems, then also the data may remain blank. So these are the reasons why our data set may be blank and we have to do proper treatment for such missing values. Now, techniques of outlier detection and treatment. We can have isolation forest, novelty detection, perform an evaluation in which we add one or more observations to the data set. Local outlier factor, an efficient way to perform outlier detection on moderately high dimensional data is to use the local outlier factor algorithm. So we can have the isolation forest, we can do the novelty detection, or we can go for local outlier factor. These are the different ways of outlier detection and treatment. So feature engineering we will study in the next video. Thank you.